Propagation modes: line of sight, sporadic E, meteor, aurora scatter, tropospheric ducting, F-layer skip, and the radio horizon. YR direct, that is not via repeater, UHF signals rarely heard from stations outside of your local coverage area. The reason is that UHF signals are usually not reflected by the ionosphere. Which of the following might be happening when VHF signals are being received from long distances? The signals are being refracted from a sporadic E layer. You saw the E layer there on our diagram of the ionospheric layers. You can have an E layer that comes and goes, and it's called a sporadic E layer. What is a characteristic of VHF signals received by auroral reflection? This is one of the things we do as hams. We play around with reflecting signals off of anything that will reflect the signal, including the aurora borealis of the northern lights. And signals that are reflected off of there show rapid fluctuations of strength and are often distorted. Which of the following propagation types is most commonly associated with occasional, strong, over-the-horizon signals in the 10, 6, and 2-meter bands? That's the sporadic E propagation again. And these are the bands most affected by sporadic E, the 10, the 6, and the 2-meter bands. What is meant by the term knife edge propagation? And I found this graphic today and stuck it in here. I used to try to draw this on the chalkboard, and this is much better. Signals are partially refracted around solid objects exhibiting sharp edges. And here you can see we have a transmitter that's transmitting signals out here. This is a shadow region for a direct wave from there, but the sharp edge can diffract signals down here into this region behind that sharp edge because of the knife edge there. So that's what knife edge propagation is. So even though the transmitter and receiver are not in direct line of sight, they can still communicate because of the knife edge. What mode is responsible for allowing over-the-horizon VHF and UHF communications to ranges of approximately 300 miles on a regular basis? That's called tropospheric scatter. The troposphere is a lower layer than the ionosphere, and sometimes they get scattering that will allow that, that kind of communications for VHF and UHF. What band is best suited for communicating via meteor scatter? It's the 6-meter band that is best used for meteor scatter. What causes tropospheric ducting? Tropospheric ducting is caused by temperature inversions in the atmosphere, and this can be pretty dramatic. I heard a story of somebody on the beach with a handheld radio in Hawaii talking directly to a fellow on a beach in California with a handheld radio because of the tropospheric ducting. A wonderful loud signal back and forth, and then it just kind of goes. It's just almost like a communications wormhole that occasionally appears. What is generally the best time for long-distance 10-meter band propagation? It's during the daylight hours. And this is a neat thing. As technicians, you'll have access to voice communications in the 10-meter band. And right now and for about the next year, 10 meters is going to be a really good band in the daytime for long-distance communication. What's the radio horizon? It's the distance at which radio signals between 2 points are effectively blocked by the curvature of the Earth. So if you think about looking out at the ocean and you see the horizon where you can no longer see any farther, same thing happens with radio signals. They come out to a point at which you can no longer see around the curve of the Earth. Why do VHF and UHF radio signals usually travel somewhat farther than the visual line of sight between two stations? The Earth seems a little less curved to radio waves than to light waves, and that's because the radio waves are longer waves. So the Earth seems to be a little bit less curved and they go a bit farther than light does.